everybody. Thank you for the introduction, Mary. So, I'm not used to speaking on a microphone. It might take me a second. So, thanks for being here tonight on this lovely evening. This is just my type of weather, actually. So, Cyanobacteria, on the other hand, they like it hot. They like the warm, they like the rain, and then the extended hot days after. So, once in a while, we might see something like this on the shore. Not anywhere around here, though, right? There's a few lakes this summer that have, well, it's not even summer yet, but we've already had 3 Cyanobacteria Advisories in the state. In Arlington Mill in Salem, Bow Lake in Stratford, and Little Island Pond in Stoddard. And it is just, like a shoreline accumulation that we see, but today I'm just going to talk a little bit about the diversity of this type of organism, the cyanobacteria, why they happen, and what the state is doing to address it. I'm not going to talk about treatment and lakes management, but I'm going to give some time to talk about that afterwards if you have any questions about that. There's just so many different types of treatment, and it's all sort of, like a research trial when these lakes have a bloom and treatment is applied. Sometimes it works, sometimes it doesn't. So I'll talk about some of the reasons why tonight. So every lake is very unique. This is a great example. You'd think that they would be the same water body. But watersheds and the flow of water are very important factors contributing to water quality. So the system on the left obviously has some excess nutrients getting into the lake, causing a bloom. Unfortunately, it has not, jumped the bridge over into the other side of this lake. But because each lake is very unique, we have to study them in depth, and we have to go deeper into the water to identify what it is, because each of these little organisms that are microscopic, that create that green color, are growing for different reasons. You could compare cyanobacteria to plants. Sometimes you have a good year with maybe your garden and the tomatoes are doing great this year, and other years you're like, I don't know what happened, it's not working out. So cyanobacteria are not truly plants, but they can have some good years, and there's some types that do very well under certain conditions. So just remember, every lake is very unique. So just because it happens in one lake doesn't mean it's going to necessarily happen in another lake. Doesn't mean that it's going to happen even the next year, because conditions change. And so a major factor is stormwater runoff in general. When we talk about runoff, we're talking about after it rains heavily, sometimes we have major storm events that the water is just running off the land so fast that it is not able to absorb into the plants and the trees or in the watershed. And that really depends on the landscape. So on the left side, we have a non-effective rainfall example. More grass, shorter shrubs, evaporation is going to occur more readily. On the right, we have transpiration with deeper rooted plants and more variety of native shrubs. So stormwater runoff is going to bring in nutrients, salt, and pollution into our waterways and help these cyanobacteria grow. So the runoff quickly runs off into water bodies rather than being absorbed into the land and the surrounding watershed. And that's one of the major factors that are contributing to the growth of cyanobacteria. On the right side, the water soaks into the ground. It's used by plants first before it gets to quickly flow into the lake. So we call this lake shores a buffer zone for our lakes. So it's really great if you have blueberries or shrubs along the shore. It's not so great when you have green flowing grass right down to the lake. And that's not to say that any one of your neighbors who has like a nice, beautiful green lawn is the sole problem for a lake, but it's that type of runoff that can bring in excess nutrients faster. And that's what the cyanobacteria really love, is to just eat up any sort of nutrients that come in right away. And so I wanted to introduce, this is a UNH, I'm actually with Cooperative Extension. They've created this manual, The Landscaping at the Water's Edge. It's a really nice illustrated guide to help you identify how you could be lake-friendly, if you will, with your gardening. So this root system of native plants is not my own drawing, or it is not from the landscape at the water's edge. But you can see on the left-hand panel, the turf and the lawn grass does not have a deep-rooted system, where a lot of the other native plants will. And again, the native plants are really the things that are going to help bring up all the nutrients that would otherwise just run off into the water and feed the cyanobacteria. So in other words, if you have green lawns, you can sometimes have green lakes. So what am I talking about? What are cyanobacteria? So that's what I'm really going to get into today. You probably will hear more than you want to. But cyanobacteria they're formerly known as blue-green algae. So if you do hear the term blue-green algae, we're talking about the same thing, cyanobacteria. The nutrients that contribute to plant and cyanobacteria growth usually really help the cyanobacteria outcompete the other types of algae in the lake. The reason being is that cyanobacteria are a little trickier than other algae and plants. So they're not truly plants, so we shouldn't call them algae. They're actually photosynthetic bacteria. And so they have a double advantage of outcompeting the other algae that can grow really well in lakes. And so if they hit those nutrients first, they're going to run with it and kind of take over and maybe bloom. And that's what we typically see. That's a nice collage of different blue-green colors that you see there. But they're not new, they're not invasive. They've been around since the beginning of time. Cyanobacteria actually contributed to oxygen on our planet, so they're not all bad. But there's thousands of species and hundreds of toxins, and researchers are discovering new toxins all the time. And one of the struggles with toxicity is just testing it. How do we test all the toxins when they produce so many different types? And I will explain that a little bit more further in this presentation. But they're also ubiquitous in the environment and globally. So they are not just in lakes. They're in the oceans, they're in the air, they're in the trees, they're in the soil. They're very much everywhere. And they're everywhere on the planet. In fact, they might even be in outer space, because there's been studies about that too. But the reason why we are so concerned about cyanobacteria is that they are sometimes toxic. Not every species is toxic, and sometimes the toxic ones can turn their toxicity on and off. They have a gene regulation where they can express toxicity, and that's not very well understood. But this is a lot of just chemistry and numbers, but basically there's a lot of different types of toxins that can create very different effects that affect people differently, affect animals differently. In a way, I wouldn't directly compare it to COVID, but in a way it is kind of mysterious in that way that somebody genetically might experience it differently. They might have a neurological issue from cyanobacteria toxins. Some people might get rashes, but it doesn't always affect everyone equally, and it also depends on the exposure. So cyanotoxins are considered chemicals. They're secondary metabolites. We're not sure if there's a real advantage for them to produce toxins. Evolutionarily speaking, it's been said that they're actually losing their toxicity. So there might have been at some point in the evolution of everything that they needed high toxicity, and maybe they don't need it as much now. But they also just benefit from producing these metabolites. They produce beneficial metabolites as well, but today I'm going to talk about the ones that we don't like and the reason why we issue advisories. So you can stay away from these because they're potentially toxic. Again, a very just busy table here, but these are just a few of the toxins. These are the few that the CDC and the World Health Organization has identified as problematic, and globally has done a nice summary. Actually, they just published something in 2021 for a nice review on cyanotoxins and cyanobacteria. Definitely check out the World Health Organization literature on that. But cyanotoxins can vary from skin irritations to death. So it's a very wide range of symptoms. Yes, and unfortunately, dogs are the ones that really end up suffering the most. They're the ones that's why I have the little green top right here, because we do issue advisories because this accumulation on the beach, you might say, okay, that's gross, I'm not going in that, but your dog's gonna love it. And we do find that dogs get very ill from being in it. Some have died. And sometimes it's just from them grooming themselves after they've been in the pond. So if you do see, this green stuff in a dog nearby, you might want to warn your neighbor, warn the dog owner that you really want to wash them off really well and hope that they didn't drink too much water. But these range from neurotoxic to neurological toxicity to nervous system failure. There's a lot of symptoms associated with the cyanobacteria. And you cannot tell how toxic one is by looking at it. But that is the chemical structure for some of those up in the upper left. If there's anyone who can read chemistry like that, I can't. I just copied the code. But another kind of troubling thing is that I just, wanted to make aware to you all is that cyanobacteria are also commercially available and are a very popular supplement. And so I was at the grocery store once, and I was pregnant, and I was looking for prenatal vitamins, and I found some that looked natural and great, but I read the back, and there was cyanobacteria in it. And there are some non-toxic types of cyanobacteria, but these types are not FDA approved. They're not tested for all the toxins. Some of them are low toxin producers, so maybe not so bad acutely, but we don't really understand the chronic exposure. There's sometimes correlations with liver cancer, sort of the digestive system failure over time. There's also been links to neurological diseases like ALS. And so the chronic exposure can almost be even more concerning, but it's not well studied. And so there are just straight spirulina, for example. Anyone heard of spirulina? Sometimes you can go get a smoothie and they'll offer spirulina for $1. You just add it to your smoothie and it's good green stuff. And it does have chlorophyll and it has some good stuff to it, but it's not being tested for toxins. And we just don't know enough about toxicity to really test it all. So check your labels. Oh, another one, ice cream. Sometimes they add cyanobacteria to make it a little green. Check those pistachio. Oh, that was better. Pistachio ice cream. Those green ones that might have cyanobacteria. So just be aware. It's not going to kill you that day. It's just something that maybe you don't want to take a supplement every day. I don't know. I'm not an expert on that side of it, but it's worth knowing. It's worth knowing that it's not just a scary thing that's in the lakes. Okay, so this is an explosion of blooms that occurred across the state last summer. Blooms don't always look blue-green, with the cyan name that they've been given. They're typically green. Sometimes the lakes look just green. There's like a green hue to it. And this kind of looks green. It could just be the reflection of the trees, but sometimes it's the microscopic cyanobacteria that are growing in abundance to the point where you can see them. And then they rise up to the surface, typically, and they accumulate, and then they kind of wrap together, and then the wind blows, and then whoever's downwind gets like the shore accumulation of this material. And it's when it piles up is when the potential exposure for toxicity is highest. So again, kids and dogs, we don't know better, just look out for them if you see anything like this on the beach, which was the case for Eastman last year. We did have a few little shoreline accumulations on Eastman Lake, or Eastman Pond, I don't know whichever one you prefer to call it, on some of the beaches. And it didn't last very long, but it did look very much like this kind of blue-green one in the center here, which I'll show you more pictures later. But to the point here is that sometimes it could just be like a white cloud in the water. Sometimes it get calls that people thought there was detergent poured in the water, someone had something going on. But this is also cyanobacteria, and once it dies, it does start to release its pigments into the water, and it is also releasing its toxins into the water as a free chemical. So when you see it turn white, it's not like dead and gone. It's probably the most toxic point at this point because it's liberating all of its toxins like freely into the water. They can be very blue. It can have like little specks. It can also be black. The black one over there is considered to be a benthic mat. Benthic mats grow very deep in the lake, and then at certain times they can rise up and then accumulate on a beach. And this black stuff is also cyanobacteria. We also see things that you might think are pollen, but it's like an orangish color. It could be pollen, but we're also finding some of our cyanobacteria blooms looking a little bit tan colored, like orange. So if you think it's pollen, probably is, but sometimes cyanobacteria will surprise you and they can co-occur with pollen, creating very brown, orange kind of streaks in the lakes, which was the case for that upper left bloom photo over there. So one of the oddball ones that are in our cleanest lakes in New Hampshire are Leotrichia. This is very common in Lake Winnipesaukee, just about Labor Day, when everyone's just trying to get one last good weekend in. Leotrichia is doing well. It does not look like a blue-green scum on the surface. It's these little tiny like balls in the water. You can see them by eye from the shoreline. They will cloud together, which I guess is more of this kind of cloud here you can't see because of the surface there, but they are like a big sunshine when you look at them under the microscope, and they have just thousands of cells protruding out of them. And they're known to produce toxins, but New Hampshire researchers have found that it produces very low levels of toxin. So when we see them, they don't accumulate to very high levels and are not super toxic for what we know, but we don't know about all of the potential toxicities of these organisms. It's always changing. Another really interesting one is nostoc. Oops, I went too far. Nostoc. Okay, nostoc is it's kind of like a green marble, and they're not going to be floating at the surface necessarily. They are usually at the bottom of the sand, or they piled up along the shore. It might be hard to see here, but all of this is just little tiny green orbs. So they're kind of cool. Like if you saw them, you wouldn't want like kids playing with them, but people actually eat these in Peru. It's a delicacy, and they go diving for them and grab them and kind of add them again, sort of like a blue-green algae supplement. But when you slice into them, they have all of these coiled little cells in them, and those each package toxins. And there's actually a connection with nostoc, this type of cyanobacteria that's symbiotically growing in some of the cycad trees in Guam. And there's been a very interesting study connecting the toxicity of this symbiotic relationship with ALS in Guam. And I'll quickly just share the story. I wish I had slides on this, but oh, that's better. Sorry, I'm still getting used to this. The Chamorro people in Guam actually they have a culture of consuming a flying fox, which is a very large bat. And they eat the whole thing, and they cook it in a cycad flour and broth. And so a ethnobiologist discovered that these cyanobacteria were growing in a cycad tree, and were able to measure the toxins from the nostoc all the way up to the fruit of the cycad, to the bat, to the people, and found a biomagnification of the toxin that causes neurodegenerative disease, and attributed that to the Chamorro tribesmen having a 250 times higher rate of ALS than the rest of the world. So it's interesting, but researchers, even as close as Dartmouth here, are looking at that correlation of ALS and cyanotoxins. And a doctor by the name of Elijah Stommel is one of the leads on that, and he's been really heavy on the theory that we might be breathing in the cyanotoxins as a fast exposure to the toxin that causes the neurodegenerative symptoms. But it's not to say that if you saw nostoc on the beach that you would be afraid of breathing it in or being near it. It's more of a consumption-based approach for that pathway to accumulate in your tissues. Another really interesting one that you might not think is cyanobacteria, but I did show you that black one before. It's like a black sludge. When people see it, they're not happy. They're like, what's going on? What is this black sludge on my beach? This is also happening in Lake Winnipesaukee. So these deep, really clean lakes are getting light down to the bottom where this stuff can grow. And with a lot of boat activity and just regular activity, weather, these can become dislodged from the bottom and come up. And it's microscopically, it's just a bunch of filaments of different types of cyanobacteria. Some are toxic, some are not, but they're usually woven together like a rug. And so this type might not be toxic, but this type might be. And so it's always sort of a guess when you see these things as to how toxic they could be. And you and I are not going to go up and say, oh yeah, let me just try it, and I'm going to add this to my smoothie. But dogs love it, and they're attracted to the odor. Animals have been attracted to the taste and odor compounds that they produce. And if you eat enough of that, it has killed cattle and horses. So big animals have died from eating benthic nuts of cyanobacteria. Another really interesting one that, just because of its color, I think is interesting. You would not expect this to maybe be a cyanobacteria bloom. You might have thought, oh, somebody made a mistake. Is there paint in the water? What happened here? But this is cyanobacteria. This is called Bornichinia. Taxonomically, this organism has been called lots of different things. However, it does create sort of this like tannish color. It can look really green also. But when it's mixed with some other organisms, like that top corner, that orange little thing there, is this blob, this like amorphous blob we found in the water. And when we looked at it and poked it, it kind of fell apart, and it ended up just being cyanobacteria morphed together with this other waxy green algae. They like to be together, I guess, and they created this form. So again, the mixture of things that are living in the water can create different colors. And when you see the surface scum, it's usually indicative that cyanobacteria have grown really quickly and have surfaced, and they might be mixed with some other things. The good news about this is this one we're not finding to be that toxic, at least in our New Hampshire studies. But again, we can't test on all of them, so it's always a caveat of, well, we don't know everything. And then finally, one of my favorites is Picocyanobacteria, and it's because you just can't see this stuff. These don't bloom typically. They can bloom, but you need a special microscope to see them. So this normal microscope, you can see a cluster and maybe some little dots, but under epifluorescence, when you really shine a light at them, they will respond. And you can see them and notice how numerous they actually are. And these guys are the most numerous cyanobacteria probably on the planet. We're finding them in our aerosol studies. They're in the oceans. They're most abundant in the cleanest lakes. And we don't know about them too much. I did a study testing the bioaccumulation of toxins from these up the food web, and they can accumulate in the tissues of organisms that consume them. There's little plants and animals in the lakes that also need to eat. And these are like the most readily available food source because they're so small and so abundant. So we use special techniques to try to enumerate them and find them, but they're not well documented because of how difficult they can be to see. So here are some resources, and of course I think I'll be sharing this presentation so you can really dive into this if you're interested, but there's a lot of good resources out there if you're ever interested in looking more into the identification of cyanobacteria. There's so many different types of groups out there doing this work, and there's a lot of just great image galleries, so you can just check out the list of really toxic ones. There's services rendered or provided by some of these groups if you're ever wanting to send a sample to be tested. So there's just a bunch of resources here that you can look at later, but I just wanted to point out a few of the ones that I found really interesting if you ever did want to get into looking at these under a microscope. One of them is from the Northwest. We need to do better and make a better one for the Northeast, but this key online is by Robin Matthews, and it's really great. It's very easy to use, and if you're interested in learning more about the biology of cyanobacteria, I recommend going to her site. And she'll just kind of bring you through the major taxonomy of what you might be seeing if you have a microscope and what certain features to look for. And the reason why I introduced that is because New England has come up with a cyanobacteria monitoring initiative. It's called the Cyanobacteria Monitoring Collaborative with EPA Region 1. And we are very much promoting people to do their own cyanoscope research, to buy into, well, not even buy into, it's very cheap. If you ever were interested in doing lake monitoring, to really look at these organisms under a microscope, to collect water for research, to report blooms, there's a whole program behind it. And we have these two keys to help identify some of the more common types that we see in New Hampshire. So if you use the key on the right, which was the Dirty Dozen, it just kind of summarizes 12 of the more abundant types we see in New Hampshire. You can read more about them though and their toxicity and how to identify them. But microcystis is the one we are concerned about in New Hampshire. We have a variety of types, I'll tell you more about that in a minute, but microcystis alone has been well known to produce microcystins, so there's the name for that. Microcystins are the most well-studied of the toxins. They can cause digestive issues, gastroenteritis. So some of the more acute, more mild symptoms acutely, but maybe more chronic issues later, liver cancer, to name a few. But actually one of the major causes of going to the hospital is gastroenteritis. And we don't really always have a good answer when we go to the doctor. Like, you must have eaten something, drank something, and try to hone in on what could have been, what was it. You could get, further evaluation of it, and you've actually consumed, it was an E. coli event or something. But a lot of times there's no answer, and gastroenteritis is a big one for microcystin. And it's one of our more common types in New Hampshire. And when we see them in our blooms, the toxicity is fairly high. And when I mean high, we do have a few guidelines on toxicity. But those are always changing, so I'll just say that the states and the federal government is still kind of grappling with how to regulate toxicity. So there are guidelines out there for recreational exposure, but New Hampshire does not go based off of any single toxin to issue an advisory. We can't do it fast enough. We know we're not covering all the toxins. So we use the visual and the cell count method so that we can quickly inform people that it's potentially toxic. But if you did have microcystis, it's likely that there's microcystin, and that's the one that's more well studied and has a few regulations around it. So when I look at a slide, I might look at all of this and ask you, do you see the one that's not cyanobacteria? Or could you guess? There's one that looks different than the rest. It's hard. It's really hard. So what we do, cell counts are not perfect, but we do an estimate based on how many colonies we can count, and usually they have some number of cells per colony. So in this, it's kind of blurry actually, but this green one up here is not cyanobacteria. The rest of them are. So when we're counting, we're kind of like pushing through the stuff that's not cyanobacteria, but the majority of that bloom is cyanobacteria. And this is just another reason for an advisory to be posted because of the unknown toxicity of it. So in New Hampshire, this is from New Hampshire DES data. I was formerly the Cyanobacteria bloom program coordinator over there, now I'm with UNH. But we found that the most common type was this type, Sperm Lenormandii. And this is usually starting right now, June. We're going to start to see blooms, and it's most likely going to be this. It's been the most commonly reported, and it's known to produce more of a nerve toxin called anatoxin. But these are the 6 most common species that we see. The top left is called Oscillatoria, sometimes Plantothrix. Sometimes that can live very deep in the lake where you don't see it, and then it will come up at times with these blue-green rafts and flakes. We've also had people report that they've gone ice fishing and blue paint came out of the lake, and it's usually Oscillatoria because it likes to live deep and dark and does just fine. That top right one over there is microcystis, so lots of cells, very toxic. This bottom left, or middle left one rather, is that Warnachinia, so that orange tannish color bloom. This one in the middle right is sort of an emerging one. We're not sure if it was misidentified previously as Anabina or Dolichospermum, but this is called Chrysosperm, and we're finding that it's not that toxic, at least for microcystins. But it can also turn the lake like a brown color, like an orange tan, just something like if that happens, you just are probably not sure you should go in anyway. We have Acanizominin. This is known to produce a toxin very similar to paralytic shellfish poisoning. And then we also have, again, Dolichospermum, and that's just a different view of it with a different type of light scope on it. Dark field, light field, basically. So that's what we're seeing. We're also not sure on some. It's sometimes very difficult to identify. So the state does encourage you to report these blooms if you see it. Again, if you even think it's just pollen, it's good to just take a photo and report it. You never know. It could, you might think, oh, I'm just kind of going to ruin everyone's weekend, basically. But you can actually save a dog. You can inform and educate your neighbors. And it's not to say that you should be scared of it and stay out of the lake completely. But an advisory is not closing a lake. It's not even closing a beach. It's really just to inform you that you want to be careful. You don't want to swallow too much of the water. If you have a rash, you really want to wash off very well after. And I do think, most importantly, you just want to keep kids and dogs out and pets because they're just more likely to swallow a lot more water than adults. Samples would be collected, identified, enumerated. We also do a freeze technique so we can test for some of the toxins. Cyanobacteria advisories are issued when a cell count exceeds 70,000 cells per milliliter. That can happen very quickly, especially when it accumulates at a beach. The towns are notified. It depends on the system though. Sometimes if it's a private community and there's no public access, it could just be shared amongst the association. But we do ask that signs are posted at any public place just in case someone's coming in from out of town, at the boat ramp, the beach. We do have press releases, maps, and social media, and we're always looking to improve our lines of communication. So if you have any recommendations on how to improve that process, let me know. There is a new person in the HAB coordinator position currently. She just started. If anyone is familiar with New Hampshire Lakes org, there's a congress this Friday, and she will be presenting there. But you can reach her still at that number and at that email, and she's excellent and she knows her stuff. So since I was at DES, I was there for about 5 years and found that in more recent years that there was an increase in cyanobacteria blooms. We also changed the communication process just a little bit in 2020, partly because of COVID. We didn't have any help. It was just me running the beach program and the HAB program. I'm always complaining about that, but at this point, we were just really relying on people like you. A lot of you did help with that lake advisory last summer, where someone saw it, someone reported it, was able to bring samples, and we really appreciate the help because in 2020 we realized that we can't ignore it when someone sends us a photo that it's not an advisory just because we don't have a sample to count. We see this, we can pretty much guess with at least 90% certainty that that's cyanobacteria and that there should be an alert. So New Hampshire DES is improving the way they communicate these advisories, but they're the same thing. An advisory and an alert is just a warning, basically, to look out for this stuff. Does not mean a closure, does not mean much more than to spread the word to look out for this stuff. And oftentimes our alerts will turn into an advisory because we'll follow up fast enough to confirm what it is and count it. So collectively, I would say in 2021, we really had 72 sort of warnings all around, 32 advisories and 40 alerts. And that was when the season was not even complete yet. There were a few more after that official 2021 data entry. And I think even at the end of November, we had a few more. And we actually stopped advisories because it started to ice over, and we're like, well, how long can we do this for? So the point is that in recent years, it could be that the public awareness is increasing, but we are also seeing the fact that our extreme weather events and development and just higher use of our lakes are contributing to more cyanobacteria blooms. And that can be shown in this graph here. This is just the number of advisory days, which there was a peak in 2008. We're not really sure exactly why that was the case, but there is sort of, this trend in more recent years of having longer advisories. And so this is what it looked like last summer in August. It probably only lasted a few days, but we can't get there very fast enough to just really determine, is it gone? We've gone back 2 days later and it's like, oh, it's gone, and then the next day someone says, no, it's not gone. So we usually give it a week for our resampling events, but I think from hearing from some of you that this was truly gone after a few days. It did reach all the beaches at some point, but it was a shoreline accumulation that wasn't very severe. We still, again, at beaches especially, would issue an advisory and have signs posted just because if other people can access them and they're not part of the communication network, they might show up at the beach and say, what is this? So a sign really helps. But we also issue these statements that are available at the DES website. So please check out des.nh.gov and subscribe to the press releases or check out the map. This is hard to see, but this is Sperm. This is what you guys had in your lake. And it's known to produce anotoxin, which is a nerve toxin. It's fast acting and can cause sort of seizures and lethargy, sometimes like numbness. And it was short-lived, and it was ranging from around 200 to 400,000 cells per milliliter when it was accumulated to that level. And this lake is also part of the Volunteer Lakes Assessment Program, which is great because you guys are keeping track of the water quality. And DES does give you a report card, if you will, and it's designated uses for aquatic life and primary contact recreation. Sometimes we do a secondary contact recreation as well for fishing purposes, but primary contact recreation usually means swimming. Sometimes people swallow water, and that's really what it's about. Aquatic life is really like how well are the organisms doing in the pond. And so we measure these parameters. We do this at the Lake Slay Monitoring Program as well. This is what limnologists do. They test the lake to kind of check the health of the lake periodically, and then at the end of the year, provide some sort of summary report card. And these do get submitted to the EPA, where at least in some cases, water bodies might be impaired for certain parameters, and that can also lead to funding to help remediate certain problems. So cyanobacteria is not on that list yet, that's good. Primary contact recreation looks good for E. coli and chlorophyll, and chlorophyll is that indicator of greenness and how green a lake is and how much productivity, phytoplankton, cyanobacteria included in that. Some of the orange is slightly bad. They said slightly bad, not terrible. But phosphorus is the nutrient that we're concerned about. The phosphorus is what really helps cyanobacteria grow. It's just like feeding your garden or your grass. They like the same thing. pH in New Hampshire is hard. We're struggling with pH in New Hampshire. It's mostly because of our bedrock and the fallout from other places coming to our New England area. And chlorophyll A, that might have just indicated that at certain times of the year when these tests were measured, that it was elevated to a point that it seemed like there was some greenness, which is not surprising because the next year there was a bloom. You can't necessarily correlate chlorophyll to cyanobacteria blooms, but it is an indicator of that algal growth, which includes cyanobacteria. So you can find these report cards at the DES website as well. And just for comparison, so this is Lock Lake, and this was last summer also around just maybe, well, it lasted longer, in August. But this one had Microcystis, Warnachinian, and Dolichospermum, but the cell count was over 50 million in these areas. This was like a thick soup, like a pea soup, basically. And this system is actually a drinking water source. So it's not it was not consumed at this point, but they were getting ready to put it online in October. So we had to keep monitoring it all the way up to the time that they were planning to use it. Because toxins can still be in the water even after a bloom. And we're finding that the duration of blooms are lasting even longer than they have been. So this one was a little more severe, and if you look at their report card, they are now on the list for impairment for cyanobacteria. And when that happens, there again can be a source of funding to help remediate the problem, but it takes a lot of work, and you need to be in a program like ELAP to understand the water quality first before treatment would be allowed. And this lake also had Anabina, which is also known as Stilligispermum. So we also tried to test some techniques out at Lock Lake. This is a fluorometer. Basically, it's a multi-probe sensor that has a probe on it that can measure the pigments of cyanobacteria, so that like blue-green color that comes out of the cyanobacteria. And they had this continuously logging near their outflow for their drinking water before they were drinking it. But they were able to continuously monitor it and find where there were peaks. And so this sort of captured that advisory event. Sometimes in the day you don't see it, and sometimes you do. And that's sort of the trouble with trying to track the cyanobacteria for advisories. And so what can you do? I've talked about this a little bit. I would encourage you to check out cyanos.org. This is a New England Region 1 EPA effort that's expanded globally. In fact, it's really grown quite a bit over the last few years. But I would encourage you to check out this page because there are different tiers of involvement if you're interested in monitoring or just learning more about how to watch out for blooms, how to monitor for them, and understand the water quality around them. And this is very much based on citizen science, so if you are already in DLAP or a volunteer lake member or are interested in the Lakes Lake Monitoring Program, you can reach out to us and we can get you in the right direction with just being on one bloom watch. You see it, report it. Cyano monitoring is testing the pigment techniques to see how much we can correlate with what we're seeing microscopically. And then cyanoscope, and that is one of the big things I tried to drive today, is that I think it's very interesting when there's at least one member who would like to join cyanoscope to get a microscope to really identify it, who could be a point of contact locally, who can say, oh no, I'm getting good at this is not cyanobacteria, and not make a big deal of it. But it's all related. So this is a tiered approach to monitoring, but they are all related, and there's a lot of really great techniques in there, and they do offer training, so just something to consider if you're interested in monitoring. And this is really my last slide because I said before I wasn't going to talk about treatment. So I have my own personal feelings about certain treatments, but I won't get into that today because I have to represent UNH. But I will say that this document, this is the Interstate Technology Regulatory Council that created a harmful algal bloom group. And this involved all of the states and all of the, there were lake associations, all of the state employees for the beach program or cyano program or their drinking water programs. Anyway, they came together to make this interactive document online. I would also encourage you to check it out because it is just such a thorough review and overview of cyanobacteria. But I think more importantly, if you're really wondering about treatment, they outline all of the treatments and all of the case studies that have happened, and it's a pretty great document. And it also has a nice photo gallery that you can check out if you're interested in the cyanoscope approach. And with that, I think I went way longer than I wanted to, but thank you. That's my email, and I'd love to take any questions if you have the energy to do it. Yeah.
Does it look like an oil slick at all? Can it look like a shininess?
It can. So it can look a little oily. Sometimes like that black one. Sometimes people think it's an oil, but you might be seeing iron bacteria, which we did have a lot of iron bacteria. 2 years ago we had a drought, right? And last year we had a lot of rain, especially on weekends and holidays. It was pretty bad. And the water table came up, and you might have seen a lot of like orange sludge in various locations, or not. There was just more reports of it last year. But when it breaks down, it can create sort of this oily sheen. It could be oil from a boat or something, but it will start to fragment into these like kind of opaque little chips, and that's iron bacteria. But we have had calls of people think that this is paint, this is oil, detergent, and it's been cyanobacteria too.
What about a stream that looks, after a big rainstorm, that looks almost orange, not even rusty, but orange on the bottom?
Yeah, that would sound to me like iron bacteria. They really like stream beds too
And
because
what
of the
is
fluctuation.
iron bacteria?
It's pretty harmless, although it can be associated with like sewage bacteria, but it's not. It's totally harmless. It's just something. I don't know how else to describe it. It's a type of bacteria that kind of produces a rusty color like iron, that kind of iron color. It's usually good. It kind of sometimes like breaks things down, like other bacteria would. But why it's happening more is really about the water table and how it comes up. It's somewhat of a phenomenon, if you will, especially in streams.
Yeah, it was after that huge heavy rainstorm,
Yeah.
the hail and so on.
Yeah, it will come up, especially with extreme weather events. It tends to come up when the water table comes up a bit more.
And one more thing, what do you think about, the drainage ditches along sides of roads and then having culverts just empty it into Eastman Pond?
Yeah, and I'm sorry, I don't know the details of the watershed of Eastman Pond, but if that's the case, identifying those is one of the first things you would want to do, is identify any major stormwater runoff events that are going directly to the lake. If it's a ditch and it's retained, that's one thing, but if it's just flowing, you got to stop that, and that would be a source to consider for watershed management.
So it's like a culvert, but I mean, it just, through the storms, it just goes, and it goes right down to the lake.
Yeah,
Into the lake.
and it's not going to a stream first and then going there, it's just
No,
right
it's
there.
going from road around the lake and down the other road, and then there's a culvert underneath the road, and it just goes right down the lake.
Yeah, you might want to contact the state about it just to see if it needs some work. Sometimes DOT can come and help, and they just kind of fix it so it diverts it better. Sometimes there's these nice little ponds that will grow in like cattails, and that's good. You want to have things kind of absorbing the water before it does go runoff, but if it's not an effective drainage ditch, you should have it fixed. And that can be hard to do. You got to work with the town, but you can start with just contacting the state and asking them to maybe just check it out. Yeah, welcome. Yes.
Hi, first, thanks for a great presentation.
You're welcome. Thank you.
I don't want to lead you down that path, but you mentioned like an example of Lock Lake where things had gotten so bad that the state actually did intervene with some sort of remediation. Can you say anything about that?
Yeah, well, so with Lock Lake, it was really just monitoring. So we didn't do any remediation, but we wanted to track it more carefully because of how close it was getting to the drinking water. And this is a new drinking water source, so they were actually required to do the monitoring. The public water system was. The only lake that New Hampshire DES has actually treated since 1978 was last year at Nippo Pond in Barrington. And it's a very small pond. For years, people blamed the golf course, but it wasn't the golf course. It could have been a little bit, but it was actually a bunch of roads, like ditches that were eroding. Erosion's a big problem. Even just the replenishment of beaches, which I think might be partly what's happening at Lock Lake. Lock Lake used to be Webster Stream, and they dammed it up, and they just developed there. And it's a lot of seasonal, A-frames. So checking septic is very important. The state will definitely make you identify all of the external stuff first before treatment. So, yeah, if there's any sort of issues with septic, runoff, or any major obvious source, the state would address that first in a watershed management plan. And then do the treatment down the road. It takes years. So for NIPO, they were coming to UNH actually, because they're part of that group. Like every June, brought in a sample. It was cyanobacteria, so we had the proof, we had the water quality data. They did the hard work of the watershed management plan to identify the sources, and then they finally raised the money and did an alum treatment last year. And the alum treatment is really a phosphorus binding chemical, so it's really just kind of being dropped into the lake, and it binds to the bottom, and it makes phosphorus unavailable biologically, but there's a chemical process involved, so they also identified that they didn't have enough oxygen at the bottom of the lake. And another factor that DES would consider is how much of that is contributing to what they say is the internal load of nutrients. So external is where you want to start, and you want to do all the hard work now for addressing external, because if you ever did need a treatment down the line, it would take years. They'd see you did all the work, and they'd say, oh, you do have a problem, we'll allow this alum treatment. And that treatment is expensive, but there is grants, I believe, available. Federal 319 grants, I think they're using. They also would require a matching fund, so I don't know the details on that specifically, but DES does have a plan for that. And we're just seeing how well this alum treatment's really gonna work. It can last for 20 years though, so that's the benefit. But it won't last if you haven't addressed the external sources. Yes.
Thank you for a terrific talk. You were just talking about nutrients being fed into a lake and mitigating problematic ponds. If there is evidence that there's a lot of nutrients coming in from a runoff from a local farm or something to that effect, and you could demonstrate periodic levels of cyanobacteria, are there legal, I'm not a lawyer, but are there any legal ramifications to limit such runoff at the state of Hampshire?
That's a good question. I might not get that right. If it's private property and it's a farm pond, and there was an obvious source of that leaching into, a stream that was bringing it to a lake, they would probably identify that in the watershed management plan. Usually you'd have to hire an environmental consultant to help really address all that, which can add up too. But they're very good because they will address individual properties and kind of give them the green or the red on how things are going. So if it's in the watershed, it should be addressed if it's flowing down to the lake. If the farm pond itself was the problem and it just had cyanobacteria in the farm pond and the lake was fine, it would be a non-issue. Yeah. Yes.
So you may know this, but last year when we had our outbreak, the first day that I recall was reported on, I think, West Cove. And then the second day, I happened to be the one who reported at North Cove, as I was stepping off the beach after a very busy day with a lot of kids swimming right there.
Yeah.
And there was a culvert on the left-hand side of North Cove Beach, as many people here know. And I'm just saying this to the group as well as to you. But it also happens to be the corner of my property, so I happen to be heading to my property. The point is that there's a culvert that's coming down there from the road. It's all sloped. And it's somewhat maintained. It's improved as a result of a washout 2 years ago. But there's also generally woods property, which is mine. And last year I observed, in the 6 years I've lived there, much more water coming down the slope because of all the wetness, all across. So my question really, or my comment is, so you've got one thing that you can kind of identify as a culvert, and then you have another thing, which is a natural shoreline, which in Eastman is typical. It's very wooded, and there's a lot of woody plants in there, as some people in the room would know. So you have two different, maybe, causes in converging there. Do you know what I'm saying?
Yeah, sure, yeah.
So it's a little bit more of a challenge to figure out how you would indeed mitigate that, if you could. That's what I'm trying to get at.
Yeah. Again, I do, the state is great at identifying those types of mitigation. There are some certain techniques, so if they could really see it and address it, there could be a way to address specifically what you're seeing. It's anything that's flowing fast into the lake that's not kind of meandering or being absorbed would likely bring in a lot of nutrients, even from the forest. And
Yeah, well, that was what I observed, it was
Yeah.
incredible, but I don't know. And then the other, third theory was it was blew in. There were people standing there talking, did it blow into that area, because we got a lot of blow into that area.
yeah, so
Of the
that's a
lake.
good point too. So wherever you see it is not really where it came from. So yes, it is growing in the lake. I mean, the stormwater runoff coming in is adding nutrients. It kind of gives it a quick burst of energy. You know, it's feeding on that. It's growing within the water column typically. In certain lakes, it could be growing, you know, maybe on one side of the lake in a nice cove, sure. But it's really kind of a lake-wide growth. And then it's usually the prevailing wind or current that helps that surface accumulation. So it could just be more of like a hydrodynamic kind of issue, you know, is it upwelling, is it pushing, is it, you know, there's probably more factors there. But I think it's good to identify these culverts and ditches or any sort of major stormwater runoff that could be slowed down.
Yeah.
Yeah. Yeah.
So, is what you're saying, if there is an idea that there might be a major source of runoff that is contributing, would the state of New Hampshire, like test that in any way, or are they available to help in that way? I know, like, we've all read about mill pond and phosphates coming in and a big source of running water. Would they like come and evaluate that?
Yeah, so they would. So there's a lot of different programs, and you guys are involved in the Volunteer Lakes Assessment Program. So you might want to address that with the program coordinator, Sarah Steiner, just to say, hey, we'd like to check, just get an extra sample, and you could do a nutrient sample just to see what contributions might be from that. Just looking at it can be difficult, of course. So we do have some other types of inspectors, compliance inspectors. You know, sometimes someone's like, oh, they're septic, I swear it's them. And we can't just knock on their door and check. But there are cases where there's a special inspector that would come out. But I think in this case, you might just have the VLAB group just grab a few more samples to really investigate any sort of inlets that you might be concerned about. Yeah. Yes.
You mentioned deep water oxygenation. Is there anything to sort of enhance that? Or?
Yes, yeah, so it's sort of a vicious cycle, and so when you have more plant growth and algal growth, so the question about dissolved oxygen on the bottom, it really depends on the lake and the depth, and there's a lot of lakes that are very vulnerable because they're just shallow, and you know, and over time, lakes are becoming a little more shallow. There's sedimentation, there's plant growth. There is these natural aging process of lakes, and it's called eutrophication. However, we are seeing that the bottoms are becoming more anoxic, so the bottom of the lake, and that's where VLAB will go out and do an oxygen profile and may identify that there's no oxygen at the bottom. And if that's the case, that could be caused from all the plant growth decomposing and degrading down and causing sort of this hypoxia. It can also just be from our lake stratifying, which they do in New Hampshire. They mix 2 times a year. We have spring mixing, fall mixing, and as the summer warms, the top layer becomes a little bit deeper, and the wind will kind of mix that top layer. So the top layer is warm. You know, if you swim down a little bit, you're like, oh, I reached the cold. And there's sometimes cold pockets. That gets pushed down more and more and more, and then that can also cause the oxygen to kind of fade out a little bit more and more and more. And that just is sort of a combined factor of many things dying as the lake, you know, how the season goes. By the fall, there's the leaves, and then there's everything that has sort of died and warmed over the course of the summer. So usually August is when the anoxia is at its worst. And if that is the case, there's a chemical reaction that allows phosphorus to be released and more biologically available. Yes?
Amanda, Kathleen Kerwin here. I'm the person who's been doing the water testing and for VLAB for the last 10 years. And we do have a problem with anoxia at the bottom of the lake, without a doubt.
Yeah.
But we did a core this winter, went through the ice and got a core, and analyzed it. And the good news is that the phosphorus that we have is not being released under anoxic conditions. So the phosphorus we have to worry about is coming in from the outside, and it's not being released from the lake bottom. So that's the first thing. The second thing is we have an updated watershed management plan that was rewritten in 2020, and we lost ground, as everybody did everywhere, because of COVID, and we're really digging in now and trying to move forward. We've identified 73 areas around the lake where erosion is a problem and is dumping nutrients into the lake. The increased storms, number, severity, climate issues are exacerbating the nutrients coming in. Unfortunately, 75% of what comes in waterways is from Stony Brook, and it comes through private land that is not Eastman land. And so getting a handle on that is going to be very difficult for us, because that's what's filling up our coffee filter, Mill Pond, and that's what's allowing nutrients to spill over the dam at Mill Pond and then on into the lake.
Yeah.
So, you know, we're working on it, and we know where the issues are, and we're going to do some more analysis on that, because a lot has changed in the last few years because of climate change. A great deal has changed. So
Yes, thank you for being a volunteer for so long and knowing all that. So definitely talk to him about what's going on. Because no, it's true, and it's very complicated. Watershed management plans can be very difficult for some of the reasons you just stated, but doing the hard work will help if you ever needed funding for treatment and to do the remediation in the future. So your efforts are appreciated and almost necessary to do anything good. Yeah.
They make phosphate binding filters. You'd wonder if you could put one at the
That's a good point. Yeah, there's like these socks basically that you can put out at the end of streams that would bind the phosphorus and kind of absorb the nutrients a bit. And that's something that I think DES is kind of on the fence with. I don't know, so I really can't say which direction they'll go in for permitting things like that. But it's definitely worth asking. Ask Sarah about that specifically. Sarah Steiner can help you. Just try a few things. You know, that's what the treatment is really like a trial, like a research trial. Yes.
So to what extent, if any, is changing the residence time in the lake an option for mitigation? I mean, we've got here a lake where there are some opportunities to alter residence time.
So residence time is how long the water stays in the lake before it gets cycled out completely. And it can be long, it could be years, or it could be like it flushes twice a year. And some of these lakes who have dams and streams and outflows can turn over very quickly. The residence time is short. Residence time can be good, like if it's short, because it's flushing out. But if the source is bad, then you know it can balance itself out. If you have a very long residence time, sometimes it's a very deep, clean lake, and it's going to keep that water for a very long time. And so it does depend on the system, the depth, the watershed, and all of these different things. But if one of you is in charge of the dam, that's one of those really difficult issues.
I would like to thank you very much for coming and doing this for us.
You're welcome, of course. Yeah. Pushing me out, right? I can take another question if you. Yes.
What about barley straw? You know, what do you feel about that?
That document, let me just bring that back. This document here, we'll go over like the case studies and whatnot of barley straw, because it's not a new concept, but I think it's been trialed a few times in Maryland, probably some other places, of course. There's a lot of different things. I like the idea of barley straw. I'm not sure of its success. So that document here will go through case studies of where it worked or where it didn't, and maybe why, how much it cost, what were the pros and cons of it. So there's a lot of different things, and that's where I don't have a strong stance on treatment in general because I do think it's lake dependent. It depends on the species. Just like plants again, you know, well, it worked on this plant, not on this plant. We have a lot of different types of species that can be hard to deal with too. But when you identify what the issues are, the external nutrients, the internal nutrients, the oxygen, the stormwater runoff, those are the things to really focus on first, and then explore those treatment options in the future. Thank you.
Thank you.
Oh, thank you again.